Okay, it's your turn. In just a second, pause the video and see if you can find these areas. You'll want to start by finding the numbers on the number line below the curve, shading between or to the right or to the left of those numbers, and then using our calculator command to find the area. If you came up with 0.630, 0.015, and 0.230, great job! The first one had a negative value and a positive value, and the shading was in between them. On the calculator, just make sure to put the negative or left value first, and then the positive or right value. For number 5, we were shading to the right of 2.18. 2.18 is already way down that number line, and shading to the right of it makes just a tiny little bit. That explains the small answer we got, 0.015. Remember, 2.18 needs to go first because that's the left edge of the shading. Technically, the shading continues to the right forever. To trick the calculator into going forever, we just put a big number like 1,000 in the second spot for the upper or right edge of the shading. For number 6, we have a negative 0.74, so down here on the left end of our number line, and we wanted to shade to the left of it, so again just a small bit is shaded, the left corner. Here's where we need to be a little extra careful. Make sure we put the left edge of the shading first, since it technically goes forever to the left. We'll put some big negative number like negative 1,000, and then the shading ends on the right at the negative 0.74, so that number goes second. Get a relatively small answer, 0.230. So we've been working on finding areas, but what we really want to do with this ultimately is use it to find probabilities. Since probabilities of all the outcomes in an experiment add up to 1, just like the area under the normal curve totals 1. So the questions will start to look a little bit different, although the way we work them is exactly the same. So notice here we're looking for the probability of z being in between these two values. So again, we'll want to find those values on the curve, shade in between them, and use our calculator command to find the area. In number 8, we want the probability that z is greater than a value. So let's find the value, shade the numbers that are greater than that. Greater numbers would be to the right of it, and use our calculator command to find that area. Lastly, for the probability of z being less than a value, once we have the value on our number line, we want to shade the values that are less than that. Those would be the ones to the left. So once that shading's set up, we can find the area and have that probability just like all the others. Take a second to pause here and see if you can get the shading in the right place. Use the calculator command to find the probabilities that we want. So first off, this z was in between two values. So we'll do the normal CDF from negative 1.83 to 0 and find that it's just under a half, 0.466. Number 2, we want to shade all of the z-scores. So think about the numbers on the number line that are greater than 0.18. Those would be the numbers to the right of 0.18. So we're going to shade to the right, which goes forever and ever. So normal CDF from 0.18 to 1,000. Area, the answer comes out to 0.429. Lastly, if we're looking for the probability that z is less than a number, that would be all of the values to the left of that number. The smaller values on a number line are to the left. So the area this time goes to the left forever. That's why we start with negative 1,000. And on the right, the shading ends at 1.28, so left to right. We get a pretty big answer this time, 0.9, once we round up. My stat lab will tell you how to round. I think oftentimes they'll be rounded to 3 or maybe 4 decimal places. So we've been rounding to 3, which means we'll use that 4th digit to help us know. In this case, we have a little bit of a domino effect. It gets rounded up, 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 all the way from 899 to 900.900.